Welcome back to Machine Learning Guide. I'm your host, Tyler Ranelli. MLG teaches the fundamentals of machine learning and artificial intelligence. It covers intuition, models, math, languages, frameworks, and more. Where your other machine learning resources provide the trees, I provide the forest. Visual is the best primary learning modality, but audio is a great supplement during exercise, commute, and chores. Consider MLG your syllabus with highly curated resources for each episode's details at ocdevel.com/MLG. I'm also starting a new podcast which could use your support. It's called Lefnir's Life Hacks and teaches productivity-focused tips and tricks, some which could prove beneficial in your machine learning education journey. Find that at ocdevel.com/LLH. You're listening to Machine Learning Applied. In this episode, we're going to talk a little bit more about NumPy and pandas. Some more depth that I didn't get into in the MLG languages and frameworks episode. So NumPy and pandas. In Python, when you're doing machine learning or exploratory data analysis or anything on data, you're going to be using NumPy. NumPy, which stands for Numerical Python. And NumPy is a very old library. It's been around for a very long time. And what its goal is to store big arrays of numbers in RAM and to operate over those arrays really fast. Okay, so NumPy is just arrays of numbers or arrays of numbers, vectors or matrices or any dimensional tensors. Remember, tensor, the word for n-dimensional array. And in fact, in NumPy, we have a construct called ND-array, n-dimensional array, which is synonymous with a tensor. ND-array, tensor. But in NumPy, they call it an ND-array, and that's the main construct that you'll be using when working with NumPy. And what it does, what an ND-array does, is it stores a list of numbers or a list of numbers and so on. Those numbers can be integers or booleans saved as zeros and ones, or very high precision floating point numbers like a float 64. And then, of course, you'll be using these tensors, these ND arrays, in your TensorFlow code or your Keras code or your data analysis, right? Everything in machine learning is just crunching over tensors of numbers. So that's what NumPy is. It's for keeping these tensors of numbers on hand. Now, if the buck stopped there, why would we even need NumPy? We could just use arrays of numbers in Python, right? Open bracket, number, close bracket. Well, what NumPy does that's very unique is it makes storing and operating on these numbers extremely efficient. Very, very low memory footprint, high-speed operations. And the way it does this is that NumPy arrays are aware of the data type that's inside of them. Okay, they could be float 64s or integers. Unlike your traditional Python arrays, which are heterogeneous, they can have anything inside of them. That awareness of what type of data occupies every cell of your ND array in NumPy allows NumPy to dictate the way that those arrays are stored in RAM. And so it will use some knowledge about whether we're storing float 64s or int 32s in order to set aside specifically sized contiguous blocks in RAM. So it's very good at allocating space in RAM in order to store these ND arrays most efficiently. And what you'll find is if you have a traditional Python n-dimensional list of numbers over here, and then you convert it to a NumPy ND array over there, their memory footprints are drastically different. The ND array memory footprint will be substantially smaller than the Python list. And I mean, this can be orders of magnitude. There was one time where I actually was running out of RAM on my 32 gigabyte PC for some data processing I was doing in Python. And so I switched it over to NumPy, and it didn't even touch. It didn't even bother my system at all. I think it was taking like 6 gigs of RAM to operate on the data at that point. So it can be an enormous savings in space and in time. NumPy will perform operations over these memory blocks all at once. It's an amazing feature. It's called vectorized operations. So to give you an example, if you wanted to square every number in your Python list, what you'd have to do is a for loop over every outer list and a for loop over every inner list and so on. Okay, you'd have to unpack your list and square every one of those cells individually. And that could take a long time. In NumPy, you would literally just type your NumPy array R times 2. And that means, in Python, times time means raised to the power of. So **2, and it'll actually convert that operation to a NumPy function. So it's an operator overload. And what it'll do is it'll snap its fingers, and in O of 1 time, right, big O notation, it will square all of the elements of your array just in the blink of an eye. It won't actually iterate over each of the element. It will do it all at once. And so these are called vectorized operations. And what's interesting, actually, is that NumPy doesn't typically execute these operations in Python. It will send an operation down to a lower-level library written in C or Fortran. These are very old libraries that have been around from, big scientific projects back when everybody was using C or Fortran, super highly optimized scientific numerical calculating systems. NumPy is kind of like this intermediary between Python and those old systems. It'll send this operation down to one of these low-level libraries, and these low-level libraries will do this extremely fast calculation for you. So NumPy is all about efficient storage in space and fast computation in time. Now, this computation thing, it gets really cool when not just when you're performing mathematical operations on matrices like dot products and squaring things and L2 norm, whatever have you, but when you're combining matrices in very specific ways, like you can mask a matrix based on a Boolean flag. So you can do something like, for every cell in this ND array, if its value is less than 0, make it 0. In other words, every value is the minimum of 0 or that value. You're cutting off negative values. You're preventing anything negative. This might look like something you would do in building a ReLU, rectified linear unit activation function, for example. And so you can sort of make an ND array mask, which is sort of this Boolean operator, and then a conditional value to set all those elements to. So NumPy is real slick. If you haven't already been playing with it in your machine learning career, you will be before too long. Now, Pandas is written on top of NumPy, and Pandas is real slick. Let's talk about what it adds to NumPy. First off, any sort of numerical storage or computation in Pandas is performed via NumPy. So if you're doing numerical stuff, it's going to defer it down to NumPy, and then NumPy will pop it over to Fortran or C. Pandas also lets you add strings, string columns, which, you're going to have those in your CSVs or your databases. And it'll allow you to do some real interesting stuff. First off, it allows you to operate in any direction in your, let's say you're working with a 2D matrix, like a typical spreadsheet, in any direction. And what I mean by that is you can either operate row-wise or column-wise, okay? And what I mean by that is if you're used to using a traditional SQL database, like Postgres or MySQL, you're used to manipulating data row-wise. You're used to fetching all rows where A, B, or C. A is less than 1, B equals false, and C equals hello. Now, there's a thing out there called columnar databases. There are some databases out there that operate the other direction. I want all the values of my column, of column B, for example, stacked in an array where A, B, and C. So instead of fetching an array of rows, you're fetching an array of values for a column or multiple columns. It takes a little while to get used to, but once you start working with Pandas and manipulating data through Pandas, you'll start to see the value of columnar databases or data processing. Now, typically, if you have a traditional SQL database, that's a row-oriented database. Or If you have a columnar database, that's the opposite. But Pandas lets you do both. And you'll find once you start getting used to it, you'll find yourself just flying through data in a way that in Pandas is just like a one-liner would have been, 10 to 100 lines of Python code for you before. And before you start getting used to doing things column-wise and row-wise in Pandas fashion, you'll think there's no other way of it. You won't think you're doing hard work manipulating data. That's just the way to do it. Then you switch over to doing things in Pandas, and holy cow, you can do this all in one line of code. Another really powerful aspect of Pandas is by way of this concept called indexing. You can add an index to all your rows in a Pandas data frame. You're like, well, okay, you can have an index on all your rows in a Postgres table. Yes, but Pandas takes it a step up. So let's just dive into an example of stock trading to showcase how powerful this indexing feature is. Let's say you're going to build a stock trading machine learning model, maybe a recurrent neural network that's going to forecast the price of tomorrow and decide whether or not to buy or sell a specific stock. Now, in this case, we're only using Apple stocks and Google stocks. So we go to some service and we pull down a spreadsheet of Apple stocks, all traded for the last some odd days, maybe 1 year. Then we go to the same service and we pull down a spreadsheet, a CSV of Google stocks, and you open it up and the days don't match. The Apple stocks spreadsheet has maybe 1 year's worth of prices per day, and the Google stocks spreadsheet has a year and a half. So they don't match up. They don't match up exactly. Well, what you'll do is you'll import these into Pandas in your Python code using a function called pandas.readCSV. So automatically you can just pull in a CSV spreadsheet into Pandas, get a data frame with one line of code. That's real nice. You'll get a data frame for your Apple stocks. You'll get a data frame for your Google stocks. You'll see that the days don't align perfectly. And what you'll do then is you'll make the dates in both of these data frames your index, okay? The days will be the index because you'll see in Pandas, it's these indexes that let you join things together, just like a standard SQL join. And then what you'll do is you'll just combine these data frames. Just combine them together, and you'll see that Pandas automatically, it created two columns. One column is called Apple, another column is called Google. A single index of all the days automatically aligned all of your stocks, the Apple on the left and the Google on the right, to the right days. Okay? What you'll get then is a single data frame with two columns, Apple and Google. The Apple column will have a whole bunch of blank entries in the beginning because Google had just objectively more data from the spreadsheets that we downloaded. So it added the Google column and it saw that Apple didn't have those days. And so it just inserts blanks. And that's very useful because you can figure out where your blanks are and what you're going to do about it. And it phase aligns these two data frames. It aligns them, it merges them together and aligns them on the date index and fills in empties with nulls. Additionally, you might find lots of holes throughout your data frame past that initial chunk of emptiness in Apple. Let's say Apple didn't trade for some specific day that Google did, maybe 6 months ago. Well, it will fill in that empty slot of Apple with a null. So again, it phase aligned, it date aligned all of your stocks together. Now, what are we going to do about those nulls, those empty holes? That's another thing that Pandas brings to bear is it gives you a tool for filling the holes. Some very complex tooling, in fact, all sorts of options. Let's say that there's a missing day sandwiched between 2 days that have a price. So there's only one missing day. Well, you take the day before and the day after the missing day, and you can average them. You can take the mean and plop that into the null value, into the empty cell. So you can take the mean of the before and the after. That's one option you can do. You can forward fill. So you could just take yesterday's date and plop it into today. You can backfill, taking tomorrow and putting it in today. Pandas gives you all sorts of options for handling missing values. Now we start to build our model and we start to see that it's having some problems. And we go back to our pandas data frame, our joined data frame between the Google and the Apple stocks, and we're like, what's missing here? Look, I've aligned all the days together, and I've filled in all the missing values. It's called imputing, by the way. Impute, I-M-P-U-T-E. I've imputed the missing values. What's missing? And you'll notice that lots of days are missing from both Apple and Google. The dates are missing. And you'll be like, well, crap. How am I going to determine, what days are valid days to trade on, but for which neither of these stocks traded? Pandas offers another tool called re-indexing. And what you can do is you can tell this data frame to re-index onto all valid dates, or all valid trading dates, or all valid whatever dates, and all those things, all valid blank. These are all like tools inside of Pandas. Pandas has a function or a constant of some sort that represents every day of the year, every date, every business day of the year, every trading day of the year, every holiday, every blah, blah, blah. And you can, what they call, re-index your data frame onto these dates. And what we'll do is throw away anything that doesn't match and create empties for things that it didn't have before. And then again, you can do your imputing. You can forward fill or backfill or whatever. Super, super powerful. So NumPy is the underlying fundamental library for storing your data in RAM. But if you really want to do sort of like SQL style manipulating of that NumPy data, you'll be taking it up a level, wrapping your NumPy array into a Pandas data frame and working with Pandas. And then we go up the stack, we go to TensorFlow or Keras, and both of those libraries will use NumPy under the hood as well. They don't really need to do these slicing and dicing SQL style operations, so they don't necessarily wrap your data in Pandas. Instead, they'll just handle everything in NumPy. But TensorFlow and Keras are both NumPy and Pandas aware, so you can just pass it your Pandas data frame if that's your fancy, and it will convert it back to its underlying NumPy data and work with the NumPy data from there. That's NumPy and Pandas. Next up, we're going to talk about how we store these NumPy arrays on disk, whether it's an HDF file, a pickle file, Postgres, what have you. See you then.